Well, hey there, it's that coding guy here. And in this video, we're going to dig into Spring Boot APIs by talking about the controllers. I think it's best to start out with these and think about layers. And in a previous video, I talked a bit about end-tier architecture and layered architecture and requests and responses. And if you need a refresher, go check that video out. We're going to dig a little deeper here and talk about layered architecture as far as the API, because the controller is one part of the layered architecture of our API in general. So I like to think about the API almost, or the controller, as the UI for the API. It's the presentation layer. It's what is being presented to the outside world. And the controller's job is to define an endpoint and basically call a method. And that's all the controller is really supposed to do. There's not supposed to be any business logic or anything like that inside a controller. So it's important to note that these arrows pointing to the right, these are HTTP requests. And the ones going to the left are HTTP responses. And so what we really need to understand for the purposes of this discussion are that the controller is defining endpoints, and when we start our server, the server doesn't really do anything necessarily. It's just waiting and listening for HTTP requests to come in that match some of those endpoints. And once that happens, then the server responds. It may respond right away if the request is bad, or if the request is good and there's work to be done, it may contact the database. But for now, this video is really going to focus on how to build a controller in Spring Boot. So I've got my Dungeon Keeper demo open over here. And this branch that I'm on is main, and I think I'm on one of the initial commits here. And I've got a room, and I've got a room repository, and I've got the Dungeon Keeper application here. So what we're going to do now is create a file for the controller. So I'm going to create a new Java class. And I'm going to name this room controller. And I'm creating that in my rooms package. IntelliJ is being helpful here, asking me if I want to add files to Git. I don't want to manage my Git through my IDE. That's just me. I like doing all of my Git on the command line. And if you're new, I recommend that you do it on the command line as well. It'll make you a stronger developer, and it'll help you understand Git at a more in-depth level. All right, so we've got our room controller class created. And at this point, before we go too far, I want to go ahead and start this server. And I apologize for those who are maybe more in the know of servers and things like that, but I'm going to be taking things really slow and really breaking them down for folks who are completely new to the idea of what the heck is an API and what are we even doing here. So I'll take it nice and slow through here. And to start this application, we'll swing into the Dungeon Keeper application file. We'll click one of these green arrows and hit run. Okay, and that brings up this tray down here at the bottom, which outputs a log of everything that just happened from us running this program. And I'm going to go ahead and close this guy here for a while and focus on the room controller. And if we dig into these logs, it's, a lot of this archaic stuff getting spit out. It's a lot to kind of like process right away. But what we can see here, a couple of things, is that one, table room does not exist, and we actually are having the table created for our room, and then Tomcat started on port 8080. So right now our service is started, our server is started. So what the heck is a server, right? We use some of these terms interchangeably. So what we mean is this API here, this API is a server. It's basically a long-running process that's listening for requests. As we said, ours is going to be on port 8080. That's the default port, and we haven't specified otherwise in our configuration. So when our server starts up and it's successful, and it is here, say, hey, Dungeon Keeper application started, and now it's waiting for us to make a request. One way we can make a request to the server is by going to a browser page and typing in localhost :8080. That's the address of this running server right now. And if I do that, I get a white label error page. It says, hey, unexpected error, 404 is not found. I don't know what you want from me. I don't have anything at this address for you. So here's an error page. Okay. Now, if we stop this server and we do this again, if I just refresh this page, it's going to time out because the server isn't on anymore. So the fact that if we start this guy again and wait for it to be done, spitting out those logs and refresh this, we get that white label error page. So our service is up. We're just not doing anything with it yet. All right. And another way to do this would be to utilize Postman. Now, Postman is the industry standard tool, I would say, for testing your APIs and making HTTP requests. So when we did this, this is an implicit HTTP request to this address and port. So we can do the same thing here in Postman. We're going to do a get, and we'll talk more about that in a second. And if we do localhost :8080 and do a send, we get the same sort of information. It's just in a different format. We can see the status code is a 404 not found, and then we get some additional information here. There's a lot to unpack with this, so we'll take it slow, right? This is actually, let's go back to this guy here. We can think of, for the purposes of today, this can be our Postman. And I'll just actually remove the UI part. Typically, this would be a front-end application, but Postman is going to be our calling client here today, or our browser page when we do that. So it made an HTTP request, so it goes out over the internet there, even though we're on a local machine. We make a request. It came into our service. Spring Boot is running our server, and it processed that request that we sent. When we hit the send button, bang, I just sent an HTTP request. Bang, I just sent another one, right? And it responded. So we sent the request, the server processed it and responded. And the response contained a status code and an object. So that's very typical for HTTP request response lifecycle. Send a request, we got a response back. So how do we change this 404 not found into something? Well, let's dig into it. All right. I'll kind of minimize this tray down here, but I'm still going to have access to my restart button. And let's dig into this controller. I want to actually, the goal here is to make an endpoint that we can hit and get a response back that is meaningful and successful. Because 404 is not a successful status code. It was not really a successful request. There was nothing there. So for our controller, let's do an annotation, and we're going to call this REST controller or @REST controller. Annotations are a way for us when we write Java in Spring or Spring Boot or another framework to kind of give direction to the framework. Because to be fair, even though we've only got a few files here, there's a lot of stuff going on behind the scenes that we're just not privy to. And for, by and large, we just don't have to worry about. This annotation here is telling Spring, hey, this room controller is a component, so please be aware of it and wire it up, put it in your list of things that you know about. And hey, by the way, and then the fact that this is called @REST controller is a signal to us semantically that, hey, this class is a controller. It's going to do controller things. All right. We're going to do another annotation here to kind of give this controller an address to work with. So we're going to do @request mapping. And we're going to provide it a value of /rooms. What this does is say, hey, by the way, this is a controller. It's going to do controllery things. And it's going to respond to requests that are made to /rooms. And what I'll say here is that it's understood that localhost 8080 is the first part of our address. Like that's the address of the running server. We saw that when we in the logs down here. Hey, this thing started on 8080. So localhost just means, this local machine. So that's our base address. And so if we make a request to localhost 8080 /rooms, this guy is going to respond. So we talked a little bit about a GET request when we sent a GET request, and let's talk a little bit about that. I want to kind of talk about the anatomy of a endpoint. So there's two main things we're going to be working on right now. One is the URL, and two is the HTTP verb. Now, the URL we've got handled. This is going to be the endpoint that we're working with. And we also want to specify the HTTP verb because we can have lots of endpoints hanging out at /rooms. So let's talk a little bit about CRUD briefly. You may have heard the annotation CRUD, or the acronym CRUD thrown around. Hey, I'm working on a CRUD application. I'm just doing simple CRUD. It stands for create, read, update, and delete. And each of these CRUD operations is associated with an HTTP verb. So create is called a post request. Reads are GET requests. Updates are PUT requests. And deletes are deletes. So we've got to pick a verb for what we're going to do, and we're going to work with a GET because this is the simplest thing to start out with. So I'm going to just kind of push that all down here for a second. And what we're going to do is define a method. So I'll define a public method. I want it to return a string. And I want to call it getRooms. It's not going to take any parameters for the moment. And what it's going to do is simply return rooms. Oops, I should have used double quotes there. So we've got a method here. When we call getRooms, all it does is return a string. Now what we want to do is have the framework run this request when we do a get at /rooms. So what we can do is use another annotation called getMapping. And that is basically telling the framework, hey, we're already everything in this file is going to be at /rooms. So when we do a get at /rooms, run this code. And the Spring Boot framework is going to take this return of this method, package it up in an HTTP response, and send it back to whoever whoever made the request. Right? If we go back to this guy and we send that request, that HTTP request to the controller, it's going to send back a response. So now that we've made these code changes, the trick for this is to restart the server. That's going to make sure that this code actually gets put into play, because we could make changes all day long, and if we don't actually restart the server, they will not have taken effect. So now that that's there, we restarted the server. Now if we make a request at /rooms, we should, yes, get a different response back. Now, instead of a 404, our HTTP status code is a 200 OK. And that is the status code for a request that has succeeded. So we get the 200 OK as a status code, and we also get rooms as a string. So this entire thing is the response that came back from our server. Now, if we tried to, do a get at some other random endpoint, we're getting that 404 not found, and we can pretty much do this with anything, and we're not going to get a good response back unless we hit a defined endpoint. And the only one we've got defined is at /rooms as a get. If we changed this to be a post and tried to send it, we're getting a different response back. We're getting a 404 method not allowed. And that's because we have rooms defined here in our controller, but we don't have a method here that handles a post. And we'll get to that in another video. So hopefully now that helps a little bit with understanding of controllers. And, to kind of go over that again, what we did is we basically used Postman to throw a ball at the API. It caught it, it processed it, and it threw it back to Postman. So those status codes, if you want to dig into those, definitely something that's good to Google because there's a bunch of them. But to break it down a little bit, 200 to 299, anything in that is a successful request. And then anything in a 400 to 499 is a bad request. And then anything in the 500 range to 599 would be a server error. or yeah, some type of exception there. And there's also 300s. I don't really deal with 300s too much. I think these are redirects, but whoops. HTTP status codes. Yeah, they're redirects. So yeah, client error, server error. I guess that would be more precise. So cool. That's controllers. We're setting up now the first part of building these APIs, and that's the ability to catch a request. And we'll get more into the other layers and more detail on controllers and doing other request mappings in a future video. Since I did bring up Git on the command line earlier, what I would like to do before we close off is go ahead and do some Git work here to show the workflow. So I'll do a Git status, and what Git is telling me is that I have added a room controller class, and it's not yet added. It's not being tracked or staged. So what I would like to do to stage this for my commit is do a git add -A. Now this is the only file that I'm committing, so this is pretty shorthand for just, hey, take all my changes and track them. All right, but in general, we do want to be very surgical with our tracking of files for our commits. So now if we do a git status, again, we can see that this is in green. It has been tracked and added, and it's ready to be committed. So we'll go ahead and make a commit. Git commit -m for message. And we'll kick off some quotes here and give a brief description of the changes that we made. So added a room controller that and an endpoint that returns a string. We'll do that there. And then the last part of our workflow here is to push. You may see some folks doing like a set upstream and things like that, where they can just do a git push, and that's it. I prefer personally to always type this all out, specify the exact branch that I'm pushing to. That way there's never any confusion about where my commits are going. I know exactly where they're going. So I'll do git push origin main to push that up to the main branch. And now when we do a git log, we can see that that newest commit has been added, and we're good to go. There's our Git workflow for that. If you have any questions about anything that you saw here today, please comment on the video. If this helped out, give me a like and subscribe for more. It really helps the channel when folks like and interact with the videos. So thanks for watching. I hope it was helpful.